Welcome back to the presentation evaluating limits using rationalization method. This is particularly used when either the numerator or denominator or both involve expression consisting of square roots, and substituting the value of x, the rational expression takes the form 0 by 0 or infinity by infinity, etc. So we are taking three examples. From the first one you see that at x is equal to 0, numerator gives you 0 and the denominator is also giving you 0. How? This is root over a plus 0 minus root over a minus 0. That means root a minus root a means 0. So the form is 0 by 0 form. This is an indeterminate form. Okay. Second one is, you see, again at x is equal to 0, the denominator gives us 0 and the numerator is also giving us 0. Root over a square plus 0 minus root over a square minus 0 means root a square minus root a square, that is equal to 0. Again this is 0 by 0 form. It's an indeterminate form. From the third example, we see that at x is equal to 1, the numerator becomes 0. How? This is 2 into 1 minus 3, that means minus 1 into root over 1 minus 1. This is 1 minus 1 means 0. So numerator becomes 0. And the denominator is 2 times of 1 square means 2 plus 1 minus 3. It is giving us 0. So again we are getting from the third one, this is also 0 by 0 form and it is again an indeterminate form. So we shall now start with the first example. Our first example is limit x tends to 0 of x by root over a plus x minus root over a minus x. Okay friends, so let's start with this one. So first of all, what to do? We shall rationalize the denominator. Okay, this is equal to limit x tends to 0 root over a plus x, this is the actual denominator, minus root over a minus x. Now we shall rationalize this denominator. So this is a plus x root over a plus x plus root over a minus x. So we are multiplying both numerator and denominator by the conjugate of this one. So this is again root over a plus x plus root over a minus x. So here we are getting limit x tends to 0, the numerator as usual x into root over a plus x plus root over a minus x divided by, you see that the denominator is in the form x minus y whole into x plus y, that means x square minus y square, like this. That means you may write root over of a plus x whole square means a plus x only, minus root over a minus x whole square, that means a minus x, and before there is minus sign, for this we have to write a plus x. Okay, so you can cancel these two a's, and now we are getting a limit x tends to 0, numerator is x into root over a plus x plus root over a minus x divided by twice x. Now one thing is very important, since x is tending to 0, so x is not is equal to 0 and this x is in your denominator. So since the denominator is not is equal to 0, x is not is equal to 0 means twice x is also not equal to 0. So you can cancel this x. Okay, that means you can divide both numerator and denominator by x. So we are just cancelling these two x's. So ultimately what are we getting here? There is half. So half limit x tends to 0 root over a plus x plus root over a minus x. So friends, what are we getting here? From this we are getting this is equal to half into, just putting the limiting value, we shall get root over a plus 0 plus root over a minus 0. So this is equal to half into root over a plus root over a, that is equal to half into 2 times of root a. So 2 is cancelled, you are just getting root over a. So the result is root over a. What is root a? Root a means the limiting value of the given function, that is x divided by root over a plus x minus root over a minus x, when x is tending to 0. This is the condition. Limiting condition is x is tending to 0. At that moment this function is tending to root over a. So the limiting value is root a. We shall now see the next example. We shall rationalize the numerator. Okay, so this is a limit x tends to 0. The denominator is as usual, that means x square, and the numerator is root over a square plus x square minus root over a square minus x square. It will be multiplied by root over a square plus x square plus root over a square minus x square. Similarly, the denominator also root over a square plus x square plus root over a square minus x square. Okay friends, now see that the numerator, in which condition, in which state it is. This is in x minus y whole into x plus y, that means x square minus y square. So we can write limit x tends to 0, denominator as usual x square root over a square plus x square plus root over a square minus x square, and the numerator is now a square plus x square. That means the formula is for x square minus y square. That means root a square plus x square whole square means a square plus x square minus root over a square minus x square whole square, giving us only a square minus x square. And since there is a negative sign for this, we have to write a square plus x square. Now a square is cancelled, so we are getting limit x tends to 0. Numerator is 2x square, denominator is x square into root over a square plus x square plus root over a square minus x square. So friends, the fact is x is tending to 0. X is tending to 0 means x is not is equal to 0. So we can write x square is not is equal to 0, and x square is in your denominator, so you can cancel these x square and x square because x square is not is equal to 0. So if we apply the limiting condition, that means x tends to 0, so we shall get 2 divided by root over a square plus 0 plus root over a square minus 0. So this is equal to 2 divided by root a plus root a square plus root a square, that is equal to 2 divided by a plus a, that is equal to 2 divided by twice a, and ultimately we are getting 1 by a. Friends, now from here have we started? We started limit x tends to 0 of this given function. This function is tending to 1 by y for x is tending to 0. Since x is tending to 0, for this function is approaching to 1 by a. This is the limiting value of the given function. Now our last example is, this is our last example. Evaluate limit x tends to 1 twice x minus 3 divided by twice x minus 3 whole into root x minus 1 divided by 2x square plus x minus 3. At x is equal to 1, the function is in 0 by 0 form, that is in indeterminate form. So rationalize root x minus 1. Okay, so a part will be rationalized and the denominator will be factorized. So we are getting here limit x tends to 1. The numerator is 2x minus 3. Only this part will be rationalized. That means root x minus 1 into root x plus 1. So we shall multiply the denominator also by root x plus 1. So getting root x plus 1. And in original the denominator contains this polynomial, that is 2x square plus x minus 3. If you factorize this, you will get 2x plus 3 into x minus 1. Okay, so 2x plus 3 into x minus 1 into root x plus 1. So friends, limit x tends to 1. The denominator is as usual 2x plus 3. Take it as usual, x minus 1 into root x plus 1, and the numerator is now 2x minus 3 into root x whole square minus 1 square. That means x minus 1. Now friends, see that since x is tending to 1, x is tending to 1, so x is not is equal to 1, isn't it? So that means if you take 1 to left side, so it will be x minus 1 is not is equal to 0. X minus 1 is not is equal to 0. And find that x minus 1 is a factor in your denominator. And since x minus 1 is not is equal to 0, so you can cancel these two x minus 1s, isn't it? So write it. Limit x tends to 1. Numerator is 2x minus 3 divided by 2x plus 3 into root x plus 1. Now friends, at x is equal to 1, the denominator is not now 0. So you may put the value x is equal to 1. That means when x tends to 1, the function gives you 2 times of 1 minus 3 divided by 2 times 1 plus 3 whole into root 1 plus 1, isn't it? So this is equal to 2 minus 3 divided by 2 plus 3, that is 5, into root 1 means 1, 1 plus 1 is equal to 2. So this is equal to minus 1 divided by 10. So friends, you just see, you just follow from where we have started. We started from this one, limit x tends to 1, the limiting case is x tending to 1, x is tending to 1, and this function, this is your function, this function is in determinate form at x is equal to 1. So for the limiting condition x tending to 1, this given function is approaching to or tending to minus 1 divided by 10. So minus 1 by 10 is the limiting value of the given function when x tends to 1. So we